In this video lecture, we're going to discuss conversion of number system from one number system, converting it to another number system. So let's start with any base to decimal. So the procedure will be multiply each digit by its weight and get the sum. So we get the positional value of each digit of the given positional value times the corresponding digit. After getting the product, get the sum of all product. That will be the equivalent in decimal. So for example, binary to decimal, we have 1010.11. So we need to locate first for the radix point. If say radix point, this is the binary point, the decimal point, the octal point. Okay, so basically it separates the whole number and the fraction of the given. So why do we need to look for the radix point? So that we could know the positional value that has an exponent equivalent to 0. Okay, so this is the radix point. Therefore, the positional value of this digit is raised to 0. Then from that position, right to left, it will increase by 1. And from left to right, it will decrease by 1. Okay? So, for example, again, based on 1010.11, radix point, left side, will have an exponent raised to 0. The positional value will have an exponent raised to 0. And then from right to left, it increases by 1. From left to right, it decreases by 1. Okay? So after determining the positional value, multiply to its corresponding digit, get the product, get the sum, and that will be the equivalent in decimal. So 1010.11 is equivalent to 10.75 in decimal. Let's have another example. So 111001. This is a whole number, so therefore the radix point is on the rightmost side of the given. Okay, so this position will have a position raised to 0. So the result will be 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5. Multiply each digit to its positional value, get the product, get the sum, and the equivalent is 57 base 10. Okay? Now let's move on with octal to decimal. Same procedure. Okay? So now the base will be raised to 8. 8 raised to the position. Okay? So we have 137.24 base 8. So locate for the radix point. And the right side and the left side of the radix point will have an exponent raised to 0. Right to left, it decreases by 1. Left to right, it increases by 1. So therefore, this will be the positional value of each digit. For 4, 8 negative 2, 2, 8 negative 1, 7, 8 raised to 0, 3, 8 raised to 1, and 1, 8 raised to 2. Multiply the digits to its positional value. After getting the product, get the sum. The result is 95.3125. Another example, 37 by base 8. Okay, again, locate for the radix point. Since this is a whole number, rightmost side, the radix point will be on the rightmost side. Okay, right of 7. So 7 will have a positional value, 8 raised to 0, while for 3, 8 raised to 1. Multiply, we have 24 plus 7, get the sum, that will be the answer, 31 base 10. Okay, another example, 7014 base 8. Again, this is a whole number. So therefore, 4 will have positional value 8 raised to 0. Okay, from right to left, it increases by 1. So the solution will be 7 times 8 cubed plus 0 times 8 squared plus 1 times 8 raised to 1 plus 4 times 8 raised to 0. So get the product, get the sum of the product. That will be our answer in decimal. 3596 base 10 or 3596. Okay, so another example. Now hexadecimal to decimal. So the positional value will be 16. So let's have an example. CAFE 0.27. Before we answer this, let's recall what's the equivalent of the letters from A to F. Okay, so A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. Okay, don't forget that. So go back to this example. So locate for the radix point. This is the radix point between E and 2. So therefore, E will have a positional value 16 raised to 0. And again, from right to left, it increases by 1. From left to right, it decreases by 1. Okay? So this will be the positional value summary. Okay? For 7, 16 raised to negative 2, 2, 16 raised to negative 1, E is 14, 6 times 16 raised to 0, F is 15. So positional value is 16 raised to 1, A is 10, 16 raised to 2, the positional value of this digit, and C is 12, positional value is 16 raised to 3. Multiply the digits to its corresponding positional value, and then get the product, get the sum, and the answer will be 51,966.152344375 in decimal. Another example, 0.8 base 16. So radix point, left side will have 16 raised to 0 for its positional value. Left to right decreases by 1. So therefore, 8 will have a positional value 16 raised to negative 1. So multiply the digit to its positional value, add the product, and the result is 0.5. Another example, 3b. Again, b is 11. So b will have a positional value of 16 raised to 0, while for 3, positional value is 16 raised to 1. Multiply, get the product, get the sum of the product, we have 59. So this is the equivalent of the given in decimal. Now, another example, E7, A9 base 16. Again, E is 14, A is 10. So 9 will have a positional value of 16 raised to 0, A 16 raised to 1, 7 16 raised to 2, and E 16 raised to 3. Multiply, get the product, get the sum of the product, we have 59,305. So this will be our answer.